Okay, today we're going to start chapter 19, and it's basically we're back to integration. And same thing with the way we had to deal with like chain rule, product rule. Now we have to deal with integration of like composite functions. And so it's basically the same idea, but there's a couple of catches. So let's start with some examples I've written on the board. The integral of 2x plus 3 to the fifth dx. The integral of e to the 5x plus 2 dx. The integral of 1 over 7x minus 1 dx. And the integral of cosine 7x dx. And so you're looking at these, and once again, like the chain rule chapter, you're saying, if they look familiar, I know how to take the integral of x to the fifth. I know e to the x. I know 1 over x, and I know cosine of x. So once again, we're going to do a substitution. So the first thing we're going to do is we're going to let u equal 2x plus 3. We're going to let u equal 5x plus 2. We're going to let u equal 7x minus 1. And we're going to let u equal 7x. Okay, now it would make sense, and the next step would be fine, u to the fifth. But the thing is, you want to bring the dx out. Like, we're not in the x world anymore. We're making a transformation. And if you notice in 19a, they're all like linear. In 19b, we're going to take it up a notch. It's not that more difficult. But the idea is the transformation is we're taking all the x values and transforming them into u values. That means we have to change dx. So we're going to take du over dx is equals to du over 2 equals dx. And therefore we're going to replace dx with du over 2. What's going on over here? Well, I want to write e to the u, but I have to replace my dx with a transformation in du. So du over dx equals 5, du over 5 equals dx, and now I can replace dx with du over 5. What's going on over here with 1 over 7x? Well, I can replace the 1 over 7x with 1 over u, but once again, I have to replace my dx with some transformed du, because I'm in the world of u now. Du over dx equals 7, du over 7 equals dx, so it's du over 7, and same idea here. I initially want to write the cosine of u, but I have to transfer my dx into my world of du. Du over 7 equals dx. You kind of start to get the hint. And 19a comes up with some rules. I don't want you to memorize it now, but just these steps. And then you have du over 7, and then we can go back. We can perform the integration. We know that this is u of 6 over 12 plus c. Right? What's going on over here? Well, this is e to the u over 5 plus c. What's going on over here? Well, it's 1/7 ln of u, absolute value of u, plus c. What's going on over here? Same idea. 1/7 sine of u plus c. Now, in indefinite integrals, we want to totally come back to the world of x, because in our course, y equals f of x, and once again, we're in the world of x. So last step, let's bring ourselves back to the world of x. And so we have 2x plus 3 to the 6 over 12 plus c. We have e to the 5x plus 2 over 5 plus c. In the third example, we have 1 over 7 ln of 7x minus 1 plus c. And in the final example, we have 1 over 7 sine of 7x plus c. Good. You can practice some of these in the book. Now let's move on to definite integrals. Let me get everything lined up. Oh, I think that's good. Okay. Let's look at the first example. You know what, I want to move this over. the integral from 0 to 2 ln of 2 of e to the 3x dx. Okay? So the question is, how do we deal with this? So you start off normally. You say, okay, well, I know that I'm going to make my substitution. I know that my du over dx is equals 3, so du over 3 equals dx. And so, you're rewriting it, e to the u, 1/3 du. Now, often kids are tempted to put 0 and ln of 2, but once again, we are in the world of u. So that means the 0 and the ln of 2 also have to get transformed. So, we're right here, my lower limit is now, how did I transform my x values? Well, it's 3 times 0, which is 3. What's my upper limit? Same idea, 3 times ln of 2. Please remember, when we're turning everything into the world of u, which means everything gets tripled. That means my 0 goes to 0, and my ln of 2 goes to 3 ln of 2. I'm going to recommend you stay in the world of u for the whole problem. Right? So once again, replace your function with u, replace dx with du, and transform the limits. So now we have 1/3 e to the u from 0 to 3 ln of 2. We have 1/3 e to the 3 ln of 2 minus e to the 0. We have 1/3. What's e 3 ln of 2? That's 8 minus 1. Final answer, 7/3. Once again, at this point, you could come back to the x world and leave your original limits, but I'm going to recommend staying in u world. Let's try the second example. The integral from -2 to 2 of x plus 3 to the 4th. So we make the substitution. U equals x plus 3. Du over dx equals 1. So du equals dx. There's really no change in my differential, but there is a change because my lower limit is now -2 plus 3, or 1, and my upper limit is now 2 plus 3, or 5. So now let's rewrite my integral. My integral now is, u to the 4th du from 1 to 5. Just solve it. U to the 5th over 5 from 1 to 5. You have 5 to the 5th minus 1 to the 5th all over 5. And that's a calculator question. Last example. I feel like I should move this closer, but I guess you can see the board, correct? The last example is the integral of sine of 2x from pi over 4 to pi over 2. Same idea. Let's substitute u equals 2x. Du over dx equals 2. So du over 2 equals dx. And now let's transform my lower and my upper limit. Let's bring everything into the world of u. So my lower limit is 2 times pi over 4, which is pi over 2. And my upper limit is now 2 times pi over 2, or pi. Let's rewrite the integral in the world of u. It's the integral from pi over 2 to pi, sine of u, 1/2 du. Okay, well, we know that this is -1/2 cosine of u from pi over 2 to pi, right? Because sine goes back to negative cosine, and we know from trigonometry we have -1/2. I'm going to pull that out, actually. And so the cosine of 180, I know, because I quickly do it in my head. I know the cosine of 180 is, so it's the cosine of pi minus the cosine of pi over 2. I know that this is negative 1/2. The cosine of 180 is negative 1. And the cosine of 90 is 0. And so the final answer is 1/2. Okay. Work on this 19A and some problems that I put in the book for homework.